Director PwC. Please sir, join DICE and start our session. Sir is the Captain Vishal Kawar, Managing Director, PwC. So he'll start the session and call all the panelists for the session. Please, sir.
Thank you so much. Great to be here. I think my introduction needs a little more to be done. So I am Captain Vishal Kanwar. I lead the aerospace and defense practice in PricewaterhouseCoopers. We are into space consulting for more than 4 years. I think we are the end-to-end space consulting practice, and the seminal work which we have done is creating the decadal vision in space strategy with ISRO and IN-SPACE. And I encourage all of you to read the space strategy document on the IN-SPACE website, which talks about where India is focusing on the space industry and space tech area in the next 10 years. With that, let me invite the panelists on the stage. We have Shailesh, Gaur, who is from the telecom, geomatics, and the policy domain. Then we have Dr. Shivangi Somvanshi. She is the center head of Center for Applied Geomatics at CEPT Research and Development Foundation. We also have an academician, Professor Manan Suri from IIT Delhi. Then we have Mr. Deepak Tawri, another alumni of IIT Mumbai, who's CEO of space startup called Geminus. And finally, we have Nikhil Saraf, who leads the engineering organization at Lepton Software, a very promising GIS and product solution space tech company. So today's discussion is centered around Earth observation and digital twins for critical infrastructure. I think after the previous session, which is looking at disaster relief, it couldn't have been a better moment to have this session. Earth observation, as you know, today the space economy, Earth observation is about $521 million as we see. And we are looking at $8.4 billion space economy just in Earth observation in the downstream. At a growth of almost more than 20%. So this is an area which is attracting a lot of investments in the space tech companies, and digital twins coming from Earth observation and geospatial information system is something which is very important. So as India expands its satellite capabilities, both the academia and the startup ecosystem is coming together to create this capability around leveraging satellite imagery. Now, satellite imagery typically, whether it is panchromatic, multichromatic, hyperspectral, or SAR, etc., is something which is the need of the hour that has to come into GIS and for future digital twins. We have many such programs which are in the pipeline. We were just talking with the panelists. There's a EO data aggregator, which the country is looking at creating, similar to the Copernicus program, which is today right now in Europe. So let's dive into this discussion and see how we explore Earth observation along with digital twins, to revolutionize the way we design, operate, and safeguard India's critical infrastructure. So let me start with Shailesh ji. Now Shailesh Gaur from Telecom, Geomatics, Policy Domain. He's worked in enterprise and government sales and business development side in national roles with firms like ScanPoint Geomatics, which is an ISRO spin-off, Bharti Airtel, Arcom, Idea Cellular, and has held also an adjunct professor position with NIS and Indian Institute of Science Campus, Bangalore. To start with, Shailesh, let's hear from you, your journey in telecom, geomatics, and policy domain. and what were your challenges and success around the journey? Over to you.
Thank you very much, Captain Vishal, for the opportunity, and SIA for this opportunity. So I started my career in '99 in wireless application network group in Hutchison Max Telecom, which is application of paging. And since then, the NTP 2.0 also started, and that's how the cellular telecommunications and telephony has picked up. And right from few thousand customers where we started my journey, we have seen that journey to reaching out to 700, 800 millions, crossing the billion, and the industry growing from less than 100 crore to a company growing to a tune of 60,000 crore and having a great impact on the entire citizen's life. So from SMS, voice, to data, to mobile data, and then coming to the domain of geomatics, which is one of the most powerful and impactful solution, which has potential to impact directly billion lives together. And the application which comes to various other domains, specifically in our smart cities program, where the large application happen in terms of ICCC, where I got an opportunity to work around with 40-odd smart cities and create that solution for ICCC, which is one of the finest example in the DPI which has come up. So, summing up with this, we have created a great DPI in the country by amalgamation of telecom, satellite application, and then the forward-looking the policy side also. And we are going to see a lot of use cases coming out of the ICCC domain and passing on to the mitigation in the disasters, managing natural resources, minerals, and a lot of other things.
Thank you, Shailesh. And this is such an important takeaway that Earth observation and geospatial impacts close to about 13 of Sustainability Development Goal, SDG goals globally. So the kind of impact it has on various sectors is immense, and thanks for bringing that out. Our next panelist is Dr. Shivangi Somvanshi. As I mentioned, she heads the Applied Geomatics at the CEPT Research and Development Foundations. CRDF is the research advisory arm of CEPT University, Ahmedabad. Her focus is on leveraging geospatial technologies, EO data, AI/ML, and advanced data analytics to support evidence-based decision-making in urban development and critical infrastructure. So we can start with a question, ma'am, that what is your experience been in applied research, advisory to government bodies, which you've been doing, and capacity building initiatives in India in EO, GIS, especially with related to critical infrastructure?
Sure. Thank you, Captain Vishal. So I am Dr. Shivangi Somvanshi. I did my PhD from ITC, University of Twente, Netherlands, and over an experience of around 15 years in applied geomatics since then. I was, prior to CEPT University, I was working with UNSTs, where we were developing national geospatial strategies for various nations across the world. And as a part of that initiative, we did several capacity building programs. We dig deeper into the overall holistic national geospatial ecosystem of various nations across different regions. And one of the very common challenge which we see is the lack of awareness among various sectors that what wonders this technology integration can do. How to integrate, how to use it. They know, okay, fine, geospatial technology is there, but how this technology can help that specific sector. So we started curating the capacity building across various sectors to make them understand that the basic as well as how this is gonna help you in terms of application. Now, at CEPT University, so CEPT University is one of the very old universities, like founded in 1967 somewhere. And this university is known for architecture and planning. So one of the pilot organization who works into architecture domain and urban planning. And we are a recognized center of excellence from Ministry of Housing and Urban Affairs. And as a part of that, we are dealing with the municipal corporations, several municipal corporations across the country, providing them solutions, various solutions. Like one of the example is identification of urban heat islands in a specific area, and then integrating that with a 3D digital model of a city to understand that which building material is contributing more towards this urban heat, which is creating. So these kind of solutions which we are developing for municipal corporations across various cities. Apart from that, this is one aspect, okay, urban planning. And we are integrating geospatial technologies in a humongous amount to various solutions in terms of urban planning, urban mobility, urban flood identification. The other very strong aspect of CEPT is architecture. And I must say that we are not moving in that direction. Till now, we haven't adopted geospatial as a part of architecture or building architecture yet. But now what we are looking forward to is integrating geospatial data along with our 3D BIM models and coming out with sustainable building architecture or sustainable infrastructure projects. So this is where CEPT is moving forward. So CEPT University is not only into academics, so they have several entities. One of their entities is CEPT Research and Development Foundation, which is into geospatial solution and services, as well as advisory services to government organizations. So we have a varied sector of government clients, be it tribal department, be it tourism department, not only urban department. And slowly and gradually, we are trying to pitch this geospatial as a solution across various sectors. Thank you.
Thanks, Doctor. And I think R&D in geospatial, especially looking at better urban design for municipalities, for critical infrastructure, it's the need of the hour. You know, all of us know as a nation we spend less than 0.5% on R&D, and that is, I would say, the Achilles heel across the manufacturing sector, across the infrastructure sector. How do we? So this is wonderful to see what CEPT is doing. I would move on to our professor who's from IIT Delhi, founder of IIT Delhi startup, Cyran AI solution, which builds indigenized GIS solutions using downstream EO analytics, edge AI systems. In fact, their geo AI solutions are well recognized and already being deployed across multiple government sectors, including defense. And this is what I would like to pose a question to him as to, can you please share experience of creating a startup on GIS solutions and product, how it is bringing in use cases, value propositions, and especially if you can touch upon something on defense, it'll be great to hear from you, Manan.
So, good afternoon, everyone. Thank you to SIA, fellow panelists. Thank you to the moderator. So our journey has been quite, unconventional for space or GIS sector. So by training, we were experts in semiconductor, extreme processing, compute. Those are the sectors that we are coming from. And it so happened that while we were designing or building systems in R&D for extreme compute platforms, geospatial data processing came as a use case. Geospatial data being heavy data by its inherent nature, and that's how we got into it. But the interesting thing is that the direction in which geospatial data and geospatial data processing or its use cases it's going, if you want to really solve that sector, we realized that the core skills or the core technologies with indigenization that you need are principles from these fields, whether it is extreme compute, edge compute, semiconductor design, data handling. So that's what gave us, and I would say a serendipitous or an accidental inroad to it. We then went ahead and built the university spin-off, the startup under the IIT Delhi's faculty entrepreneurship program. we won the 2021 we won the Ministry of Defense IDEX challenge on AI-based space data processing. This was in fact even before the formal DEF space challenges were launched. The 75 DEF space challenges were launched, and thereafter we started working with lot of ecosystem stakeholders in defense security particularly, and that's how we managed to solve the use cases, and our solutions are currently widely deployed, and they are among the first few solutions to actually clear the field trials of the services to meet their requirements, and also they have been widely appreciated because it's close co-development along with the user community. So the good thing is that the government and the policies supporting it has even included our solutions in the 5th positive indigenization list, being the rarity from academic startups or anything beyond DPSUs or big players. Now, you mentioned specifically about the context of defense and EO or digital twins. So defense, particularly, what drives most of the use cases is the OODA loop, which stands for observe, orient, decide, act, and then these days you have to also assess what has happened after you have acted. So each of these stages, EO is inherently a part of it. Before you do something, you need to, or before anything happens, you need to constantly observe. That is your ISR, or that is your monitoring. So that is where EO comes into picture, right from the. So each of these 4 or 5 steps, and the more peculiarities, whether when you are acting or you're deciding in this loop, that is where you also need more precise ground precise information. That is where your digital twins come into it. And so that is so defense becomes a classic use case of these 2 themes of this session, EO and digital twins. And if you ask me what is happening, initially probably the digital twins utilization was maybe less or only for very specialized cases. But with time, I foresee it getting more deeply intermeshed in all stages where only EO was also just used. So that is in short, my opinion about this thing. So.
Thank you so much, Professor. And I think this is very well said. Using digital twins and EO data for reducing the life cycle of OODA loop. I would add another thing, increasing probability of detection. That could be another principle. And I think what you mentioned on OODA loop, digital twins in the defense could also play a big role in maintenance and reducing the downtime of aircraft, etc. So I think it's amazing. And to hear that you won an IDEX challenge, it's very creditable, because I know these challenges are not easy to win, and I think they proved our capability going forward. So I think now we can hear from another IIT alumni, Deepak Tawri, who is the CEO of Geminus, a space tech company. This company focuses on automation and aggregation, including ground segment operations. And I want to mention here, there are very few private companies in ground segment operations. Mostly it is held by ISRO as we speak now. And this is an area which we have assessed in PwC, which has a huge market potential for private companies to come in for ground segment operation. Deepak also has a software development background. He has served as space software in a company called Antares. He's done constellation simulation and also done software development for operational platform in the last 3 years. So Deepak, we would like to hear from you your journey of the space tech company, with special reference to space data aggregation and ground segment operation, because in this since we are focusing more on Earth observation and digital twins, if you can highlight from a space tech company how the space data value chain comes across, and what has your experience been on a space tech company which is focusing on space data.
Hello. Thank you, sir. So before I come to the software and tech side, I'm just taking a step back, journey as a citizen. Digital twin, of course, is well established. What it can do for smart cities, what potential it has, what are the technologies which can enable it, it's all well understood. And we have eminent speakers, subject matter experts, so I will not go into that. But what about the EO satellites into digital twins? So as a the one common sense tells me it brings monitoring at large scale. That's first thing. Periodicity could be different, but it brings the monitoring large scale. You can monitor large assets of the city. And of course, it can be complemented with the data collected by drones and IoT devices and all those things. But what it can capture in one go would take so many, either manpower or so many devices on ground to collect that. If the monitoring can be at that large scale, next thing that comes to my mind is, shouldn't the transparency also be at that scale to larger mass? And when I say transparency, what does it mean? I'll come to that. So me being part of Citizen Forum and Ward Committee in the city of Pune, had a chance to work with civic officers very closely at the corporation level, ward office level. And the conditioning from that experience tells me no matter how smart digital systems we make, of course it's useful, a lot of information, a lot of insights, but until we have the transparency in the processes, the operations, the upkeep of what to be done by human elements, it can spoil good projects, and I have seen that, and also waste a lot of public money. So, I would say I feel very strong about transparency enabled by technology. And for example, if the roads constructed or the flyovers, if the contractor says 90% complete or so quality, those kind of false information can be prevented. A lot of these things can be automated. Water bodies can be watched, like their banks are shrinking, the builders are dumping construction materials, all those things that I have seen in Pune, it just comes to my mind. All that can be triggered automatically instead of somebody filing an RTI, getting information and those kind of things. So if the transparency factor is enabled, and also if some kind of public dashboard for people to see, common mass, where they can see themselves and give feedback, they can participate in this good governance. I think that this digital twin will become a true twin. That's what I feel. Now coming to the tech side, you rightly said, on the ground segment, as I've been attending the space conference for the last 3 years, I'm newbie in the space domain. It's just last 3 years I've been here. I see a lot of action, a lot of traction, discussion about the upstream part, how to launch satellite, how to build satellites. But on the ground segment side, I have not seen so much of as much traction as I see in the upstream side. Number of ground stations and the ease of getting the data and the automation to process it and until it becomes real image which can be ready for analysis. Those kind of things I think we need to work upon. Otherwise, what's the point in satellites taking images and it takes so long to downlink, or it's the data comes down is useless, right? So there is a need, maybe need of more ground stations, or worldwide we can use ground stations of friendly countries to get the data sooner. So all these kind of use cases, including digital twin, can be enabled. The latency is much lower, can be much more useful, and it can be real time. Thank you.
Very valid point, Deepak. Especially ground segment. Globally, companies are providing ground segment as a service. That's a new business model which is evolving, and we see a huge playbook here with companies coming into ground segment operations. Thanks, Deepak, on that. And we'll move to our next panelist, Nikhil Saraf, who, as I mentioned, leads Lepton Software, a pioneer in GIS production solution, primarily to the telecom sector. He's a Cornell University alumni, where he conducted research on building digital twins for cities to help urban planners and design walkable cities for the future. So a lot of experience on specifically GIS and digital twins, the relevant subject. So Nikhil, we would like to hear from you on Lepton's products, solutions, and how they are the backbone for major telcos, as we understand, for their fiber optic networks, and going how has your journey been building that, I would say, market position for yourself in the GIS space?
Thank you, sir. So, hi, I'm Nikhil again. I'll just introduce myself. Lepton is actually now almost a 30-year-old company. And, unlike some of the other panelists here, what we primarily focus on is serving the private sector. And we consider it almost our responsibility that whatever new trends in technology, whatever new research is being done by the academia and by the great universities here, we consider it our responsibility to bring it, operationalize it, and productize it for the private sector. Make it useful for companies in a very practical way so that they can start, taking advantage of something like this. So starting back in the early 2000s, when maps were not even digitized yet. So, most maps were even just printed on paper, or we just had imagery. And you had this telecom sector booming. They had to establish almost millions of kilometers of fiber network across the country. And so Lepton's product at that time called Network Access was the product used by almost all major telecoms to design the entire fiber network. So almost 90% of the fiber networks in India have been designed, planned, and operated on maps built by Lepton on ground. So, I've heard stories of people literally all night tracing like kind of paper maps and satellite imagery on these big boards, and eventually we would digitize them and then, provide them to companies via our products. And then they would be doing simulations, kind of route planning and things like that, and that's how they would be able to actually make use of all the kind of satellite imagery that was being produced. Because just in its raw sense, these companies would not be able to do really much with it. They did not have the competency to actually make use of the imagery for their telecom purposes. We're moving forward now. The 5G revolution is coming in, and now all of the planning actually needs to happen on a 3D level, because with these shortwave technologies, it's so relevant and so important that you actually have a digital twin of the city on a 3D level, almost at sub-meter accuracies. And so Lepton over the last 5 years has actually developed the most expansive kind of 3D building data set for India. Is being used by companies like Jio, Airtel, and all to do all their 5G planning. We actually now take this forward to other industries as well. So for example, ads is something that, the public sector doesn't really appreciate as much. But what we do is we help companies use things like, NDVI, other bands and satellite imagery to do things like, malaria risk prediction. So one of our companies actually runs ads in specific localities, in specific areas based on analyzing satellite imagery to figure out where there's a high risk of malaria, looking at kind of stagnated water, looking at population density, vegetation, things like that. In the retail space, what the retail space really cares about is, where is the growth of population happening? Now the census only happens once in 10 years. What we do is we actually take satellite imagery as frequently as we can, and we do kind of change detection to figure out where new population buckets are coming up. And we help retail companies figure out, okay, this is where you should be establishing your next store, or this is where you should be expanding your business. So our entire focus is taking all the work that the public sector is doing, the research companies are doing, and making it super practical, no matter what era we're in, making it consumable by private sector companies so that they can, they can grow their businesses and they can make use of this. Now, similarly, AI, ML is the new trend that is coming in, and we consider it our responsibility to bring it to our products and bring it to the people. Digital twins becomes very relevant is, I feel like digital twins have existed in some form or the other for almost 30 years. I consider Google Maps like the first digital twin that was kind of very widely used. And the idea is behind how we define a digital twin is, it's at whatever fidelity you're able to model the world around you, be it the processes, the people, the locations. That's only stage one. What becomes super interesting is once you're able to run simulations on it, then you're able to do experimentation on it, then you're able to do kind of scenario analysis, and eventually all of this, once a computer can actually think of an experiment, run the experiment as a simulation, see the results, you can actually run a whole automation loop now. So, we do this for telecom companies where we help them grow their fiber networks almost without any manual involvement. We automatically take a new area, we consider all the various fiber layouts that are possible. We do the simulations on which would be optimal, and then we just suggest them directly, this is where you should be laying down your fiber. And so I think what digital twins really enable, along with AI/ML, is this kind of very efficient decision making in these companies, where you're trying to remove all kind of errors that would come from humans applying their own intuition to this process, and just make it almost a pipeline where the computer thinks of experiments to run, runs the experiments, evaluates the results, and decides on what is the best thing to do. And so I think what we want to do is continue this thing of whatever the EO space is coming in with more granular data, more high resolution imagery. We want to make it useful to the private sector as quickly as possible, so that the companies can also grow along with the public sector. Thank you.
Thanks, Nikhil. I think that was a very good insight into where Lepton is going, and especially the points which you make on digital twin, decision making, ability to simulate, ability to use 3D models along with the future 5G. And I think those are very relevant points, and especially if I would say that defense is one area which are using digital twins in a big way. Companies like Palantir, Andural, building digital twins for whether it is war fighting, combat capability, maintenance, logistics, supply chain. So I think a lot of use cases from there can be adapted in the civil domain also. Thanks so much, Nikhil. So I think now this next round of question which I'm going to ask everybody, this will be the difficult part of the question as to what are the challenges. And we need to be very candid, unless we are self-critical, in my dictionary, you don't grow. So you have to be self-critical, and you have to be able to measure how do you grow on a periodic basis. That is how growth happens. And those are the two things that we really need to focus on in this part. So coming to you, Shailesh, given the fact that you have a lot of experience in telecom, geomatics, and also policy domain, what do you think are the bottlenecks or challenges you see, both from the supplier, which are the space tech companies, and the users who are creating the demand for EO data and digital twins? Yeah.
So I'll be talking much from the perspective of urban infrastructure, so which is a pressing problem for everybody, as Deepak mentioned, from citizens' point of view. So apart from being professionals, we all are firstly citizens who experience the urban infra service each and every day. And it's not unknown to everybody that what lacks our urban infra. And though Smart City Mission has been very ambitious project, only 40% of the money has been parked to actually to the ICT-based development, rather 60% going to the area-based development. And now at the end of the Smart City Mission, and what are the outputs which we have gained, so which is still yet to be seen and be experienced. The pressing problems of our top 16 cities, why I'm naming top 16 cities, because they contribute to around 50% of our GDP and 70% by our urban population. And our much of the growth which is going to come from the GDP is through the urbanization, which is a proven fact. And around 600, 700 million people are going to live in the urban areas. Though our Smart City Mission have addressed 100 cities, but those top 16 cities, if I name, and all our 4 metros, plus Bangalore, Pune, Hyderabad, and the upcoming like Ahmedabad, Indore, Kochi, and Coimbatore, and cities like that. Traffic remains the #1 problem. Flooding in urban infra remains the #1 problem. Lessening of green cover remains a bigger problem. Another big problem is a lot of encroachment which has really happened. Fourth problem is the municipal finances. Now if we see all these 4 problems, it can only be addressed through Earth observation piece only. So taking the first problem, which is of encroachment. There's very simple technique in image processing, which is change detection. So once we have our properties mapped, we have already seen Surat as a case study, where Surat collects historically for last 10 years, more than around 90% of their property tax collection. Vis-a-vis, our average property tax collection is only 40% nationally. Post GST, property tax contributes much to the municipal finances. If the municipal finances are strong, they can deploy it in urban infra in very good way. And Surat has been a great example, because Surat is also a very flood-prone city. In last 100 years, 20 plus times floods have happened in Surat. Latest one was 2006 devastating flood. So coming from that perspective, once the property tax system is matched, you get higher boost in your revenues. If you make it in 3D, you can use that same system for emergency drone delivery. Once you have all the height and all the thing measured, once you have the right dam also, you can do the flood simulation part also very well. Though the floods happening, urban floods, is man-made flood because of the wrong planning, encroachment, and various other things. Once all the properties like commercial, housing, industrial, green cover, everything is mapped, you do a change detection, it gives you clearly where the encroachment has happened. And it's a big problem out there. So the city which I come from, which is Udaipur, a lot of encroachment happening. They say that on the hilly region, more than a 15 degree of slope you cannot build, but they find it building, and later on becomes a problem. Third problem, which is AQI, which is known, Delhi is the bedrock of that, heat island, which can only be solved through Earth observation, with support as a great decision support system, which is very transparent, empirical, and proves to be an actionable insight. Fourth is the traffic. We have live data now coming from our own Indian platforms like Maples, where they collect the telemetry data, Google Maps, which is there. And once we do the traffic simulation also, and find out what is the congestion length at various other points, what are the major congestion areas. So much of that can be solved with the old design principles. But then you will have a solid decision support system also, which is one of the key things which is required for all the bureaucrats, because they think that once that is backed by data, to make things move faster, it will be very easy for them. So either it is for approval of flyovers or underpasses, or having right decision for U-turn or smaller things. So these are certain things which is through Earth observation can be solved. And of course, digital twin is a great enabler to make things happen, do things right in first time, which is the most pressing requirement, because capital expenditure budget of most of the urban is 20-25%. If we do things right in first time, much of our problems are solved. And digital twins remains as a great enabler, because the principle of digital twin says that you receive static and dynamic data live. When you have that live static and dynamic data both along with the 3D built environment, it is a very, very empowered decision.
Thank you so much, Shailesh. And I think those are very interesting points. And I think the problem statements which you spoke about, encroachment, I'll give you an example. When we did work with InSpace, people who claim tax rebates on agriculture is stopping now, because with satellite imagery, you know, in that 1 acre of land, if you're taking a tax rebate, have you grown anything in the last 1 year? If it is lying barren, obviously you come into the question of whether you should get a rebate or not. So I think satellite imagery, EO, has huge solutions. The challenge is, how do you increase the adoption? And I think that's the biggest challenge we have. So moving on to Dr. Shivangi, similarly, you know, with your experience in R&D, etc., what are the key challenges and opportunities do you see, and also bottlenecks, on using EO data, digital twins, automation for critical infrastructure? Maybe you could also address some challenges which, you know, Shailesh brought out. Over to you.
Sure, thank you so much. So as Shailesh mentioned, that these are the areas where EO can give you the solution. In order to accept any technology, be it a digital twin, be it Geo AI, we are doing so many things. What we need, the basic necessity is data, and the biggest challenge in data. So, for example, as an architect, I have to design an office building. I have to design a building, and I want to know, for designing a building, we use BIM. We develop a 3D model using BIM, and BIM give us everything what is there internally. Where's the wall, where are the pipelines, and all those things. But if I want to adopt a digital twin to give me a holistic view where my building will be. I want to know what is the status of the underground utility there, from where I can get that data. I know that as a part of Amrut, government is collecting that data. But can I get the access of that data? If I want to know which will be the nearest connectivity, the roads and the networks, I know as a part of PM Gati Shakti, we are collecting that data. Do we have the access of that data? So I want to know, I want to make my building energy efficient, use the maximum utilization of the natural sunlight, how to place my building on a real-time basis on ground. So we use very fancy terms like GeoBIM and all those things, but the base is integration of geospatial data and the BIM technology together to develop a sustainable thing. So the biggest challenge which I see is data collection or the accurate and authoritative data. I know as a businesswoman, if I have to pitch something to my client, this data collection component is having the maximum weightage. For me, it is good. I'm earning a lot because I will do everything from the scratch. I'll do LiDAR mapping, I'll do drone mapping, and I'll charge this. I'll charge because we do not have the access of the ground data. And the reality is that we have so many national level programs going on. As a part of Smart City, we have so many IoT data is there. As a part of PM Gati Shakti, as a part of Amrut, and now Naksha, right? So everything is there. But data integration and accessibility of that data is not there. So that is one biggest challenge. If I'm talking about this is a small project. Now talking about a big infrastructure project which covers 3 states. In India, we work at state level. And every state is collecting their data. Fine. Swamitva claims, Gujarat is also collecting their data, Maharashtra is also collecting their data. But there are no standards. I mean, I'm not saying that there is no standards. Standards are already there, but standard adoption and implementation is not there. Very, very simple. My center is also, providing PMU for PM Gati Shakti of Gujarat. So we deal with 12 government organizations within Gujarat itself. Now, just a very simple challenge is the data which we are getting from these government organizations to put into the PM Gati Shakti portal. Data collection pattern. Some of them have developed their Excel sheet with latitude first and longitude at the second. Where the other one, they have kept longitude first and latitude. And now when we integrate, a road in Ahmedabad I can see it somewhere in US. So, because there are no standards, now they do not know that how to collect the data. Standards are there, but again, standards, they are not aware of it. That's the biggest challenge which I see. So there are 2 things, accurate and authoritative data, access of this data, and data developed on standards. To make it more accurate, that has to be a standard. Otherwise, it is again, next level of chaos dealing with that data. Yeah.
Very well said, and I think everything starts with data and reliability, access to data, data collection, data aggregation, and standardization of data. I think very well made points, ma'am. And I think this is the bane of like somebody. Once we have a discussion, there is no AI without data. If you don't have accurate, reliable data, you can't have AI. So I think very well brought out, ma'am. So I think let's go to Manan now. Manan, we would like to hear from you the academia perspective. You are in IT Delhi. You have actually created a startup which won an IDEX challenge. Fantastic. So from the academia perspective, what do you see the Earth observation and digital twin perspective from how can academia take it further, and what are the bottlenecks? Because I'll share a concern with you. We do a lot of work with DRDO and ISRO. So when DRDO or ISRO goes to academia, they give a project which is typically funded by MOD or say any of the institutes. Suddenly they'll realize that the students pass out and the focus on the project shifts, right? Whereas if you look at Massachusetts Institute of Technology or Georgia Tech in US, they're able to retain that focus in that specific R&D, say applied or fundamental research or any of these things. So your thoughts on this from the academia perspective in EO and digital twins?
Yeah, thank you. So I think one place where really academia has to play a big role, and also which needs to be stepped up, is on the skilling side, because as this sector, so I feel if we talk about the space sector in general, or space, whether you put EO, downstream, digital twins as a vertical of it, we are in a phase right now which is an acceleration. So if you look at the entire sector as a cyclic up and down, so it's currently in an acceleration phase. A lot of things are going on, so that inherently calls for skilling, more skilling, more skill creation, more workforce creation. So that is something that is definitely to be done by the academia. And it's also happening as we speak. More new programs are coming up, maybe not at the same pace, but the programs are coming up. That's again in lieu of the requirement from the industry. So it's a supply-demand training kind of thing. Now, specifically with respect to your query on not fulfillment through academic projects, through ISROs or DRDOs or anything. What happens is, like, okay, let me give you an example. So up till few years ago, for the academia, defense was only something was via DRDO or ISRO. But now, the services, the users directly have access to academia. They have opened up more in the last few years. The specific example is the ADB, the Army Design Bureau, the Naval Design Bureau. They have their offices, liaison officers pointed in academia. So it's for the first time that the academia is beginning to openly interact with the service user. I mean, there have been cases before in the previous environment also, but now more widely, students, faculty, they are directly first-hand interacting with the requirements of users. What is the user operational workflow? What it takes to be there, and projects which are going through that direct interaction, they are showing results faster. They are showing more, better outcome. And probably, so I feel, in my opinion, that somewhere having too many, intermediary layers between getting R&D done or outsourcing R&D, the things are lost in translation, because again, the intermediary may be a system integrator or might just outsource a component of the R&D to the university, and that again. Now, there are logistical aspects to it. Funding granted, a project sanctioned. If the in the rigorous sectors like aerospace and defense, if the funds don't hit the users or the developers in a very short span of time, you are bound to encounter situations where teams have changed, students have moved to other projects. So timelines are of essence. So I often say it's never the quantum of fund which would make a difference, but the procedural timelines or the procedural bureaucracy. Even if you give small funds, but you release it really fast, you let the project fail or succeed very fast, those things will show more results. So those are the challenges which I think are being improved, and they need to be emphasized more in the time to come. So
Thanks so much, Manan. I think that really gives us hope, and the insight which you gave us about services directly reaching out, and which is again, the DARPA model where we are reaching out directly to the academia, and I think I would also like to add that, like, if DRDO, ISRO, or government R&D institutes reach out, another thing is happening is the companies also now reaching, private companies coming to academia, like it happens. Lockheed Martin sits in, I heard they have an office in Massachusetts Institute of Technology, a permanent office. So you could have private companies associating more and more with academia also going forward. So absolutely great points. So I think now I would like to hear from Deepak on, obviously he brings his experience around the space startup of Geminus. How do advancements in ground segment automation, because ground segment is what we are looking at. What do you see ground segment automation advancements taking place, manifesting in India? What are the bottlenecks? What are the challenges? In other words, I'm asking you, why is the Indian space tech industry more attracted towards satellite manufacturing and launch vehicle manufacturing rather than coming to ground segments and downstream? You know, what are the bottlenecks? What are the challenges?
Thank you, sir. So again, like 3 years back when we started journey in space domain, building software for space, one thing look at the digital twin use case. To enable that, to power that, we're not talking about 1, 2, 4, 10 satellites, like 50, 100, like more than that, right? Even for ISR use case, like India is launching so many satellites, right? So the old way of doing things, operating, designing satellites won't scale. We need the power of software, need automation for all of the satellites. To operate them, that is just 50%. As the satellite, numbers of satellites is exploding, so is the number of ground stations also has to scale up and to collect the data in time, right? And again, the way ground stations are operated today, I'm not a subject matter expert in that, but what I learned from my colleagues and experts, it won't scale either. So on both sides, needs to be complete automation, and software can empower what it has done in other fields, it can do in the space domain. And of course, now coming back to the ground segment, I think that part is not so well understood because the space domain is exposed to private sectors just recently. And ground segment also tend to be capital intensive, probably. And if somebody wants to automate the whole ground segment operation, there has to be standards how to interact with antennas of different satellites, different vendors, for example. And if unless there are standards, it's difficult to do automation. Same thing for digital twin platform. I think one big challenge, again, from software point of view, I'm seeing, and ma'am also highlighted, the interface of this portal, the digital twin, to all the other departments, or whoever is getting insight from this portal, those standards have to be defined. Also, the data that is ingested in the platform, those schema and those things has to be defined. And also the learning from one digital twin of one city versus other one, that has to be, of course, there. And again, as a citizen, I'm talking about looking at what I saw in Pune, the nearby villages, that should also be considered as part of the digital twin because they become part of the future cities. That's another thing I wanted to bring up. So in terms of challenges, of course, I think the software automation for upstream, downstream, ground segment, and that's the product we have built in Geminus space to automate the ground segment side. There's no brainer, that has to be done. If you have to manage satellites and ground stations at scale, definitely. And coming back to as a citizen again, that's very close to my heart. This digital true twin dashboard should be accessible. The visibility should be given to civil society, to citizens. All these encroachment problems and water bodies, they're getting polluted, all these things, these are seen by even people. Obviously, this will be very popular use case for like digital twins. And as people participate, there is accountability. Of course, the system will work, but it should go to the common mass. The visibility should be given to common mass. Then I think that the digital twin will I would call that true twin or truthful twin of the city. Thank you, sir.
Thanks, Deepak. I think our esteemed panelists have brought in so many insights. We are a little short on the time. But Nikhil, if you can just bring out top 2-3 challenges you face, on products and solutions on digital twins, we'd really like to hear from you.
Yeah.
Go ahead.
So again, I think I'll speak from a private sector perspective. I think, I totally agree with Dr. Shivangi that, just like with AI models, it's if there's garbage going in, we'll get garbage out of the digital twins as well. I think, what we face as a challenge is a lot of our companies want a great sense of, the cities that they're kind of trying to grow into. They want to get a very granular idea of, where, not necessarily PII, but what kind of people are there, what is the kind of business activity going on, what are the crime rates, what are the kind of environmental factors. Now, naturally what we would expect is that there are a lot of this aggregation of data can happen at a public sector level. The government can aid, and I think there's already work going on with like creating a national registry for a lot of corporations to actually contribute GIS data from all these different sources. And then I hope what eventually happens is that this is made available to private sector companies, because there's obviously, while the public sector has a huge role in affecting people's lives, you know, in large sectors, it is the private players who eventually do a lot of development on the ground, who do a lot of actual, you know, delivering value to the customers. And they're really dependent on getting a lot of data, because they're not survey teams, they can't go out and actually go and collect all this data themselves. So while Lepton does play a big role here, and we go out and we have massive survey teams that goes on the ground and tries to collect this data, even we are limited by the scale that we can achieve. And what we are hoping is that, you know, the kind of data that the government collects, if they're able to make as much of it public as they feel like, you know, is safe to, it will actually aid the private sector a lot. You know, for example, there's this product called Google Earth Engine, where they take all the Sentinel satellite imagery and all, and they open source it for the whole world to consume. And not just open source the data itself, but open source it in a way where the APIs are provided and the programming interfaces are provided, that we can develop applications on it. As you know, as an engineer just out of college, I could use that data and do like, you know, kind of malaria risk analysis on it. Now, what I'm hoping is that all the data that is collected by the Indian agencies, they're able to put it out in a way that is consumable by, you know, developers, by companies, by application builders. And that is how, you know, a lot of the value will actually get delivered to the end customer, is because, you know, the end customer doesn't actually go to these government portals too much and all. The value comes to them once these things are made parts of products that these customers use in their everyday life. You know, so for example, Google Maps, so much of investment went, you know, by Google to build that. A lot of the value is delivered not just on the basic maps, but, you know, we use things like Swiggy, Zomato. A lot of the value is actually delivered once these things reach end customers through the products we use in our daily lives.
Sure, absolutely, Nikhil, absolutely. Short of time, you know, the point you made is absolutely accurate, and I must say that the new space policy, the vision is to provide free data up to a resolution of 3 to 5 meters. In India, it will happen. There is a EO data aggregator platform which is coming, and for the entire 1.4 billion people, they will have free access to about up to 3 meter resolution. Obviously, lesser than that, submetric resolution would be at a price, and this is the model which Copernicus program in Europe also follows. That data should be available free of cost, but I think Dr. Shivangi also made this point: data collection, data acquisition, reliability, and standardization is the need of the hour. So we just have time for 2 questions. Yeah, yes, sir.
Good afternoon all. My name is Jigish Patel, former Group Director, ISRO Ahmedabad. I have 2 small questions. One, to Dr. Shivangi. While designing for the skyscraper, there is a soil test and wind load calculation, because we are doing wind load calculation for our antennas and all that. So is there any system prevailing that you are using the wind load and soil data from IRS and remote sensing agencies data in real practice?
Yes, for soil, yes, but not for the wind load as of now. It has not been integrated into our models yet. But yes, we are looking for some more accurate information if we can get from somewhere. But soil we are using from the ISRO data itself.
Right, because I think wind load is a major role to play while you are going for skyscraper.
Yes.
And nowadays in Ahmedabad, they are given the permission for multi-stories building more than 25 or 50 stories. Secondly, please.
No.
Okay. Yeah. Secondly, my question is to Shailesh Gaur sir, that right now I am technical advisor to Siddhi Engineering. There is a standard ISO 14000. There is a clause for environment sustainability. Whether it is a pollution is for companies and some products is like that, that it should have environment constraints. So is there any satellite earth observation data can help for these kind of agencies really for the ground? They will survey which factory is giving which kind of pollution and all that. So then it will be easy to cover that agency, that data in the ground. That is my question.
As I told that the data is being accumulated from both the sides. One is from the sensor side, which is the AQI measure, and of course the satellite side also. So these are two prevalent sources which are there. You want to add?
Thanks. I would also say, especially for the AQI, when we see the European model Copernicus, so whilst Copernicus has own satellite Sentinel, which they're giving data, but they have ground-based sensors also. And these ground-based sensors are deployed in the Mediterranean, in Atlantic, coastal areas of Europe, along with even in the English Channel and Baltic Sea. So they are also providing information for weather. So they kind of corroborate, and there's data fusion happening, and I think that's where we need to get it. If we have a EO data aggregator platform using EO-based satellites, then it needs to be corroborated with, say, sonar buoys, which are there in the coastal areas, and likewise for AQ measurement, etc.
Yeah, so I just want to add on to this, because our center worked with ISRO only for their Vegas platform. Because in this Gujarat, we have only 4 ground stations, air quality monitoring stations, right? So we use Sentinel data, we use the Google Earth engine only to develop the complete model, and building on AI and ML on the data, verification and everything. Now, I think it's there on Vegas platform now, that you can see the AQI of those locations also across Gujarat where you do not have ground monitoring stations. So this kind of work we did for ISRO only.
Thanks. So sure. I think what Dr. Shivangi, you can also have a conversation of the panel. We have another question. Yes, sir.
My name is Vinay Dadwal. I worked for 38 years in ISRO, currently at NIAS. Thank you all the panelists, because last week we exactly had a panel at the Space Earth at NIAS, which worked, spent almost 1 hour on digital twin. So what we could understand is there are digital data set, there are 3D data set, and the digital twin. To be really qualify as digital twin, if you act on it, the system responds also. There is a response also as part of the digital twin. So one is whether such use cases are coming up, because the type of data which will go into a responsive twin is quite different from just a optimization in 2D or 3D. The second important point is when we have data which will obviously for a city or anything have come from that, we are stressing standards but forgetting machine readable, fully compliant metadata. Even assuming there are multiple standards, but if a metadata is not fully machine readable, then it can't be collated. And third, about the Earth station, since I headed NRSC and we established an Antarctica ground station, our antenna used to be remotely controlled from Shadnagar, almost 13 passes a day. So automation of antenna is not the challenge. The challenge is all the satellites which people are making, what frequency and what is the data rate, what they will be providing. Thank you very much.
Thank you, sir. Very valid points. I'll just request the Professor Manan if you can answer the first part of the question on the importance of digital twin being more responsive. And then Nikhil, I'll request you on the second part of the question. Yeah.
Yeah, so absolutely, because I think what sir is referring to, responsiveness, or ties into the simulation part of it. And needless to say, the simulation, most of the good simulations will be physics-based, physics-backed, or in some cases where the physics is not understood, it will be empirical. So the response, quality of response, whether it is for any planning, any modeling, it will be as accurate as the data is. And if the data itself is of suboptimal quality, so it can start from some things as basic as your DEM layers, or what are the models, the geodetic models that you're using them, the Z direction accuracies. It can start from something as basic as that. And also, I'll just, the second point also was very relevant. I'll just, the machine readability. So standards, that comes from the side of interoperability. The moment you have many different sensors, many different sources of data, while data standardization from AI/ML point of view is one important thing, for data ingestion, just for basic data ingestion, the standardization for the machine to be able to extract crucial information from all pieces even before you start AI/ML. The code digitization or ingestion is also of paramount importance. So.
Nikhil, you like to add something?
Yeah, I mean, I think Manan touched on this, but I think it's hugely important for any digital twin, because what you're going to do is get a lot of data from various kinds of sources, and it's coming in from, let's say, GIS companies, coming in from EO companies, and what eventually becomes relevant is that you're able to stitch up these different layers together, and there it becomes really important that everything is annotated with extremely rich metadata, so that, for example, a building is represented as a building in across these different data sets, and once you are able to aggregate data from different sources for one unit, now it becomes very relevant that a machine is able to actually use all of that to build models on top of these things. So I think it's, your point was very relevant, that we need a lot of really rich metadata structured in a certain way, standardized in a certain way, and also, all designed to be machine readable, because eventually it's going to be machines that are going to be doing all of the processing on that, really not up to human scale to be able to do any of that.
The question is so interesting. We have another panelist who wants to answer. Deepak, yeah.
Hello, thank you. Yeah, sir, I stand corrected. NRSC has done great job. ISRO has done great job so far. I didn't mean to question like whether they are able to automate it or not. What I meant to say is like the scale at which the number of ground stations are going to explode and the number of satellites we are managing, like what like Uber kind of thing does for cars, like something more automation may be required to scale and automate the ground segment operation as well as the operating satellites. Having said that, and of course, all the experience NRSC, ISRO has, they are helping private industry. I myself have visited NRSC twice to learn a lot of things. I attend their workshops, so definitely. But as the private sectors, they had to deal with ground station systems and satellites. What more can be done is what I was pondering upon. Thank you.
Thank you, sir, and thank you, panelists. I just like to sum up. Great to hear Shailesh's insight on the problem areas which EO can solve across traffic, AQI, etc. Dr. Somvanshi, it was great to hear from you on the main problem area of data, the entire space data value chain of acquisition, aggregation, standardization. Professor Manan, your insights into geospatial data analytics using how you run an IDEX channel in IT, and what academia can do in R&D, whether it's fundamental or applied research for digital twins, adoption of EO data. Thanks for this insight. Deepak highlighted the importance of ground segments, and I think great to hear from Dadwal sir also on his experience in ISRO. And finally, Nikhil, your insights on digital twins, going at 3D level and bringing in 5G in future digital twins. I think I see about 4 or 5 takeaways. One, Earth observation and GIS is no longer a support tool. They are foundational to tomorrow's society of solving problems. And this just gets supported by how EO is impacting 12 out of 17 SDG goals. Digital twins, second point, represent the future of infrastructure management. And like what you rightly said, Shailesh, is unless you have using digital twins, you will not get it right in the first way. Third point is looking at policy and urban governance for data collection, and the point where Dr. Somvanshi made important. And I think the challenges persist on 2 sides. One, adoption of EO data for demand generation and digital twins. And second, creating space tech companies who are able to make digital twins to the level what Dr. Dadwal mentioned, of being responsive and at a level where it can be used for decision making. Thank you all panelists and audience for I would say very energizing discussion, and let's hope some thoughts which have come here continue beyond this discussion as well. Thank you.
Thank you so much, sir. As a token of gratitude and appreciation, we now present a mementos to our eminent panelists. So our session moderator, Captain Vishal Kawar, sir, please present the mementos to Shailesh Gaur. To Dr. Shivangi. To Mr. Deepak Tawri. To Mr. Manan Suri. And last to the Nikhil Saraf. Thank you, sir. Now may I now invite Mr. Rajiv Gandhi, Deputy Director General, SIA-INDIA. Please present the mementos to our session moderator. Yeah, please, sir.
We have amongst us Dr. Dadwal, Professor Dadwal here. Professor Dadwal, may I request you to kindly come to the stage and do the honors, sir.
Please put forward for the group picture, please, to all the panelists also. So one group picture, please. Please, ma'am. Thank you so much all. So the lunch is being served at the Inspire Hall and near to the Desire Hall. So we'll resume our next session at 2:15. Thank you.